evaluations of some sort or another. And I'm curious, in comparison to how you evaluate sort of traditional machine learning techniques when you're developing a new one, what sort of metrics have any of you used when you've done user evaluations of the things that you've done? I like the smirk and the laugh.
Shall I go first?
Sure.
I think we have tried to, so we focused quite a lot on, in our work, did it improve the training? So improvements in accuracy, but at the same time we also looked at satisfaction, mental load, task load, that kind of thing. We also sort of started to measure trust. So in this work, how much do you trust that machine learning system? So what we're trying to do, at least in my work, is not just solely look at, oh, this is good for the system, this is good for accuracy, but also take the human side into account. Well, what effects does it have on the user? And I think that is really, really important if it is going to be human-centered in any shape or form.
Yeah, I was going to add, so we focused on not only correctness, so we did sort of a scale of very simplistic questions. So using that animal data set, it's not a very complicated data set, but it did have lots of things that our users didn't know about. So we focused on very simplistic questions that you could probably answer with simpler tools, and then looking at, can they actually get the right answer? So we want to make sure the tool can still do that. But then on top of that, we're focused more on exploratory interaction and exploratory analysis, where we want to see if they actually gain insights from the data. And by insights, I just mean new things that they didn't know already. And we came up with sort of a way to grade those insights to see, well, if we give them this tool versus just static MDS or an Excel spreadsheet, does that change the complexity of those insights, or the dimensionality or cardinality? When you talk about an insight, did they talk about 5 different characteristics, furriness and all these other things, or just 1 or 2? And then cardinality as well. Did they talk about a cluster of animals, or just 1 or 2? And normally the more complex ones were the ones that involved more information. So that's sort of how we did everything.
In looking at this stuff, it occurred to me to wonder, especially, do you say it's as Simone?
Simone, yeah.
Simone, sorry. Is anyone out there doing explanations for why the machine algorithm or model might be wrong or bad? Like, I'm unaware of anyone doing that. I know a lot of people there. You show the model, you show explanations for why the model is right. Is anyone giving the devil's advocate point of view automatically? And would that be a good idea?
There was a study that tried to explain why the model made a mistake, right? Or that soldier study. And it had a finding that I actually wanted to ask you about this anyway. In that study, people were finding that they basically gave the machine the benefit of the doubt if it explained why it was wrong, right? They would say, oh, I make mistakes, I see why the machine made a mistake, and then they would trust it inappropriately in the future, even though it had been wrong in the past. I'm sort of wondering if you had dug a little deeper into why people were trusting the really comprehensive explanations, or had any thoughts on why?
Well, so for example, to answer your question, why did they trust them more, or actually change their minds? We found they were saying, oh, it's giving me lots of reasons why I shouldn't believe that, and then they switched their minds, even though they kind of went, I don't think that diagnosis is right, but it knows so much more. By persuasion. I think the sort of other point of why is there no devil's advocate kind of thing? A lot of the systems that people are dealing with have no ground truth as such. And I think then it's really, really hard to point out the obvious mistakes. Although it would be really interesting to sort of develop almost like a sort of testing suite for machine learning models that an end user could actually use rather than a machine learning expert.
So, I mean, I think it's sense you refer also to this differential decisions, or what did you call it?
Differential diagnosis.
Just kind of, I think what you're alluding to is like sort of like a second opinion kind of model. So maybe you give a recommendation and also like the next best, and then the user can get a sense of like what could be alternatives, and then.
Yeah, and I think there is also something else. Like, do you plan to do long-term studies? Because my guess is that the way users trust certain prediction will change as they spend time working with the system. Like if someone gives me advice, it depends what I know about this person. And it will really change according to how I know this person makes decision or give advice. So I don't know if you plan to have something long.
Doing anything long-term in that domain is a bit tricky because quite often these research prototypes, and then eventually they might see the light of day several years down the line. Currently, I'm doing a study where I'm actually looking at the impact of the severity of mistakes on trust and so on. And that's not long-term, but it has a temporal aspect to it, which I think is actually not looked at sufficiently, because obviously Laura is going well, accuracy is 80%, and leave it at that rather than going, well, how does the accuracy actually change over time?
I could answer that question partially because I do some research in clinical decision support tool, and I know in the U.S., at least in the U.S. hospital system, decision support tools still remains the least used feature among all in electronic health system. So it is, I think it is interesting that you mentioned the trust issues quite a lot, but I think it's always important to think to have like how the confidence of the users, of the healthcare providers, and how the confidence of the algorithms interact, right? There are sometimes the users shouldn't trust the algorithm, and sometimes the explanation might be the confidence interval, or like giving some kind of intuition of whether the user should trust it or not. Sometimes two perspectives.
Yeah, I think that's a really good point. I mean, nothing in this study was considering the expertise of the user either. They had, I think, at least 6 years or an average of 6 years of experience post-training. So, but those are usually the people that are targeted by clinical decision support systems, especially in this domain where, you want to sort of broaden the or put the expertise and embed it into a lower level. But, you have to consider the end user.
Yes.
As well.
Okay, Wendy?
Just a quick comment on that. I did a bunch of work years ago with air traffic controllers, which is a different type of safety critical system. One of the things that they said is that after 6 months of so for the first 6 months, they did not trust a new intelligence system. And then the danger came in at that 6-month point when they started to trust it, but some very rare event would come in, and that they were losing their ability to have the expertise to do it without the system, but at the same time, the trust hadn't been put there. So there's these kind of long-term issues when you're dealing with real human beings. It's not just did I make that right choice now on Google, but rather, once you get into safety critical, it's a whole other level.
I think sort of, I think it's important that to realise that we're dealing with very different beasts in a way. Although there might be all involving machine learning in some shape or form, but some of them are clinical or safety critical systems. Some of them classify furry things. And so, it might be that we need to design these systems completely differently.
Just maybe a bit more of a point. I'm quite interested, certainly in Jessica and Joel's presentation, the fact that you were both talking about looking at different ways of representing and interacting with the systems with machine learning. And potentially that's a really important part of the picture because there are very different levels. And I'm kind of reminded of a lot of 3D graphics tools like Maya. You do lots of direct manipulation, but hey, you can bring up the numbers and you can type in the X, Y, and Z coordinates, so you can sort of tweak very, very finely sort of details of the system. So I guess I'm going to turn it into a question. How important do you think that sort of multiple representations is, and how could it be applied more broadly?
So with ours, we found that most people didn't necessarily care about the actual raw data values. What they cared about was the differences between the raw data values. So is something higher or lower? And is it a lot higher or a lot lower, or just a little bit? And we do have a way, and I think I never actually did it, where you can, once you have clicked a bunch of points, you can hover over a weight to see the raw data values if you want. But we found that in this type of analysis, people didn't tend to do that. Now, depending on the type of data, if you guys are talking about very more sensitive and really definitely different than the animal data set, people may be more interested in numerical values or representing things in different ways. So I think it depends highly on the actual data. And we've thrown lots of different data into this tool, not just the animals. We've done the classroom with people. We've done paleontology data, biology data, looking at how certain genes are affected, or how certain plants are affected by different diseases and things. So it's a varying amount, but most of the time people tend to not always care about the actual raw data, which is interesting.
Yeah, and I think it also depends on the kind of users that you have. And I think in your case, you really want to, you don't care about the model because you don't want user to care about how it is actually making prediction. And I'm actually doing the opposite because my experience to work with musicians really led to that they want to understand how the model works, and sometimes it's like, okay, but it's naturally following my gesture in time, or when I do it like this, it doesn't really work anymore. And I think in this case, bringing a visualization of the model itself gives a possibility to do something else than the task that was initially, the initial task. And I think this is very interesting for more open-ended, probably.
Yeah, we definitely found in all the many studies that we did, giving them to different types of people, most of our studies were with graduates, computer science students, but we also had other types of students from other disciplines. And the ones in computer science tended to want to know more about the model. And that was in our original study, which also had some design flaws with the interaction. Things didn't really happen the way they expected, so they blamed it on the model, which I don't blame them. That's what we expected. But it's interesting that people coming from biology, they trusted it a little bit more than the computer scientists.
So I think the takeaway is that explanations really depend on a lot of different factors: the task at hand, the user, as you talked about, and the data. I liked also the model being a part of this as well. And Jules, you mentioned this sort of idea of affordances of these models, and how can we, maybe reveal them so that you can then, shape, the user can be involved in shaping the models. And you use the H&M, I think, in your example, and I'm just wondering if you had thoughts on other affordances of other models? Like I can imagine like decision trees kind of afford splitting, you know, different nodes if you thought about different models.
Yeah, yeah, I don't know. I've worked mostly with hidden Markov models and Gaussian mixture models, and there are already something different in that one model has no temporal modeling at all, and hidden Markov models have temporal modeling. So what the possibilities that they give are completely different. For example, the way that they will interpolate is completely different, and yeah, so I'm really curious. I really want to explore with other kinds of models to see, yeah, actually what they inspire in terms of.
I want to put a pitch in. Baptiste and I have a book chapter coming out in a few months where we, part of it is proposing the use of this idea of affordances to talk about machine learning algorithms as something that's complementary to the other theoretical properties that we usually talk about. And it's a starting point. I'm definitely not going to claim that we've exhausted the possibilities of this, but I'd be interested to talk to more of you about it as well as use more of it.
Where's it coming out?
Oxford University Press, Handbook on Algorithmic Music.
Can you put the link in the Google Doc?
Yeah, I can do that.
Any other questions? I guess let's thank our speakers again.